starting our chapter on rational expressions and rational equations. We'll mainly talk about rational expressions first. Now, a rational expression is a fraction whose numerator and denominator are non-zero polynomials. So we're going to have variables in the top and the bottom of the fraction, is what's going to make this a rational expression. Now, the domain of the rational expression excludes all values that make the denominator 0. Anything that makes the bottom of the fraction 0 will not be included. We have to exclude those values because we cannot divide by 0. We cannot have 0 in the bottom of the fraction. So anything that's going to make the denominator 0, we have to exclude. Well, for this here, x cannot be 0. That's the only value that wouldn't work. So if we look at any of these rational expressions, we're going to have to figure out what values of x or y or any of the variables that would make the bottom of the fraction 0. And the other part is that it has to be in simplified form. We can't have any greatest common factors or any common factors between the numerator and denominator. If there's a common factor between the top and bottom, we have to simplify it. Well, no other common factors besides 1. 1 doesn't make a big difference. It doesn't change anything if we factor it out. Okay. Now this is kind of just the same thing what we've done before with like fractions, 15 over 65. Well, there's a common factor between them. So we simplify it out. We get rid of it. The same thing is true with our polynomial expressions. If they share the same polynomial expression, we simplify it out. We simplify it down. So let's go on and take a look at some of these here and see how these work. So if we look at this first one here, we want to simplify it. We want to reduce any common factors or remove any common factors from the numerator and denominator, the top and bottom of the fraction. So what would be a common factor between the numerator and denominator, the top and bottom of this here? 2, yes? I'm just going to get the mic in there. So this 2 and which other? The 4? Well, unfortunately, no. Highlighted. Because whenever we have this x plus 2, those are stuck together. We can't separate those. Because if I have an x plus 2 on top, I can simplify it with the x plus 2 on bottom. So unfortunately, that doesn't simplify. Well, there's also an x on bottom. Well, if there's an x on top, I can simplify those, yes? Because x divided by x would be 1. Do we have an x in the numerator? Is there any common factors between the top and bottom? Well, no, this is as simplified as it gets. But we still need to figure out what our restrictions are, what x cannot be, because the denominator still cannot be 0. We still cannot have 0 in the denominator. We cannot have 0 in the bottom of the fraction. So what that's telling me is that x and x plus 2 cannot come out to be what? 0, yes? Well, if I have two things multiplied together, so we're saying x cannot be 0, and x plus 2 cannot be 0, yes? So they can't equal this, correct? So how can I find a way, so what can I do with this to actually find out what values of x will make it 0? We can solve these, can't we? Because if I want to know what value would make it 0 so that I can figure out what it can't be, we can solve. Because we don't want x or x plus 2 to be 0, but I can set it equal to 0 to find out what values x cannot be. Well, luckily, one of them is x cannot be 0. So what would we do to the other one? X plus 2 equals 0. We would subtract 2. Because those would cancel and tell me x is equal to -2. Well, so if x is 0 or -2, it's going to cause the denominator to become 0. We can't have that. Those are our restrictions. So really, when we're trying to find the restrictions for a rational expression, we're trying to see what values of x or y, whatever the variable is, will make the denominator 0. And so to find that, we'll just set the denominator equal to 0. Questions on this here? Okay. Well, let's look at this here. Now, everything's kind of written in a nice form. And before we simplify anything, and there is some things we can simplify in this one, let's figure out what our restrictions are first. Once we find the restrictions, then we can move on. Now, if I look at this here, well, we have two things in the denominator. We have x plus 1 and x plus 3. And again, we cannot have a value of x that's going to make the denominator equal 0. Well, to figure that out, we can set x plus 1 and x plus 3 equal to 0, because if I want to find out what value of x will make it 0, why not set it equal to 0 to figure that out? But with x plus 1, what can we do? We can subtract 1 from both sides, because 1 and 1 will cancel, telling us x is equal to -1. We can. We'll do that here in a minute. Now, that's a good point, because we will factor that out. We'll simplify it out. But even after we simplify it out, it still will be a restriction. It still will be a value we cannot use. It'll be easier to work with, but any restrictions we have at the beginning before we simplify will still be restrictions even after we simplify. That's a good question. Now, the other restriction, we can find it by subtracting 3, telling us x is equal to -3. So these don't work, and these will be two of our restrictions. X cannot be -1, and x cannot be -3. These values do not work. Okay. Any questions on the restrictions before we start simplifying? We good with this here? Yes? Okay. Well, let's simplify. Well, what's in common on top and bottom? Well, the x plus 1, yes, because I have x plus 1 on top, x plus 1 on bottom. Since they're the exact same, we can simplify them out. Anything divided by itself is what? 1. So what's left on top? Well, we have 2 over x plus 3. 2 over x plus 3. So again, you're going to have to do stuff like this on your homework assignment. And it's not going to just ask for it simplified. It's also going to ask for the restrictions. It's also going to ask for the restrictions. Yeah. It is. And it's also going to ask for the restrictions, what values of x cannot be. And that's going to be our -1 and -3. It's going to ask for both. Okay. So just kind of like the last one, we have two polynomials. We just need to see what sets or kind of what's in common with top and bottom and simplify it out. So what's in common on top and bottom? Well, we have an x squared and x squared, yes? Would they cancel out? Well, not really. The plus and minuses, those addition and subtraction signs, especially when division, we're looking at this here, lock everything together. So the x squared minus 4x minus 12, that is all stuck together. I can't just cross things out. The same thing is true with our x squared minus 4. Those two are stuck together. But luckily, we've spent all the semester so far on figuring out a way to fix this. What can we do? We can factor. We can factor these. Now, which one's going to be easier to factor? You guys would want to factor first. X squared minus 4 or x squared minus 4x minus 12? Which one looks easier to factor? X squared minus 4. Well, what is x squared minus 4? It's the difference of perfect squares, yes? Because this one here is, I think, y'all like this one a little bit better. It would be our two sets of parentheses. We'd have our plus and minus. So the factors of x squared would be x and x. And what would be the factors of 4? And 2. And they worked out to be the exact same thing. Because our difference of perfect squares worked out to be, first, our two terms, and both of them were the same. We just had an opposite sign. And when we're simplifying this here, and when we get into multiplication and division, and we get further along, this here, finding out which one you can factor the easiest, is going to be helpful, and it's going to make this easier. Because what are we wanting to do? We're wanting to simplify, yes? So I have two sets of parentheses on bottom, and I'm going to have two sets of parentheses on top, yes? If something simplifies, what do we know for sure? Well, what do we know one of these here is going to end up being? Right, because if one of these is x plus 2, well, the x plus 2 and x plus 2 would cancel, yes? If one of them was x minus 2, the x minus 2 on top and the x minus 2 on bottom would cancel, yes? Oh, yeah, because anything divided by itself is 1. So what are we hoping? We're hoping one of these, either this one here or this one here, matches one of these two down here, yes? Because if they do, they're the same and they simplify out. This is why I said it'd be good if we could find whichever one's easier to factor, because it kind of gives us a hint at what it might be. So let's look at the factors of the numerator. X squared minus 4x minus 12. Well, since we have minus 12, the signs are opposite. One's going to be positive, one's going to be negative. The factors of x squared are x and x. Let's look at the factors of 12. 1 times 12, 2 times 6, 3 times 4. Which one would we want to use? 2 and 6, because it'd match up, yes? Would the 2 be positive or negative? And we can check this here and make sure we got this right. X times negative 6 would be negative 6x. 2 times x would be plus 2x, which would give us negative 4x. That's exactly what we wanted. So these are set up correctly. And so the reasoning behind 2 and 6, well, if I do 2 and 6, I will get a set of parentheses that will match up. I need that as one of the factors. Any questions on how we factored this here? Are we good with this here so far? Yes? Okay. Now at this point here, we can find our restrictions on what x cannot be. We can find our restrictions on what x cannot be. And so we look at this here, we're looking at what's going to make the denominator equal 0. Well, if I want to solve it, so find out what values will make the denominator 0, well, we can just set the denominators, the x plus 2 equal to 0, and x minus 2 equal to 0. We can set both of them equal to 0 and solve for the value of x. If we do this here, well, x plus 2 equals 0. We can subtract 2 from both sides. These will cancel, telling me x is equal to negative 2. We can do the same thing to the other one by adding 2 to both sides. And it'll tell me x is equal to positive 2. So really our restrictions, x cannot be equal to positive or negative 2. Because either one of those values will make the denominator equal 0. Any other questions on this here? Any questions on anything we've done so far? Okay. Now we can simplify. What's it the same on top and bottom? Well, the x plus 2 and the x plus 2. And if we simplify those out, what are we left with? x minus 6 over x minus 2. Well, wait a minute. Can we reduce the 2 and 6 on this here? No. Because of the minus. Because it's x minus 6 and x minus 2. Now, we don't normally write this when we only have one set on top and bottom. But really, we can think of it as this here. That x minus 6 is in parentheses, the x minus 2 in parentheses. They are locked together. Now, is it possible for us to rewrite this in a different way? Well, yes. Because this here is the exact same as saying x over x minus 2 minus 6 over x minus 2. This is possible because we can break the numerator up because that's the same thing. Because when we add or subtract like things, we add the numerator as long as the denominators are the exact same. But going from here to here, does that make it any simpler? No, it makes it more complicated. We don't normally go this way. We'll go this way. We'll push them together, try to make it a little bit simpler. One term is simpler than two. But we won't normally split those back apart. And that is it for that one there, as I draw a line. All right. Let's look at another one. We're going to look at a few of these today. We have x squared minus x minus 12 over x squared minus 9. Do we want to factor the numerator or denominator first? Denominator, x squared minus 9. Well, that would be a difference of perfect squares. We'll have plus and minus. One's going to be positive, one's going to be negative. Factors of x squared are going to be x and x. And the factors of 9 are 3 and 3. Any questions on this here so far? Okay. We're also going to need to factor the numerator. So since the 12 is negative, our signs are opposite. One's going to be positive, one is going to be negative. The factors of x squared are x and x. And now we need to find the factors of 12. So what factors of 12 would we want to use? 3 and 4. Which one's going to be positive? Which one's going to be negative? There's this here. And we can check it to make sure we got everything in the right spot. X times negative 3 will be negative 3x. 4 times x is going to be plus 4x, which will give us, yep. So we'll need to switch the signs. It'll be negative 4 and plus 3. So we'll need to switch those signs. So it's still good to check it to make sure we have the numbers in the right spot. Now, again, we could simplify here because we can see that the x plus 3 and x plus 3 are the same, yes? But we need to be careful doing that because if we go back and check and find the values of x are restrictions of values of x that don't work, sometimes we'll eliminate those out because we still need them. So we could do that first and set x plus 3 equal to 0 and x minus 3 is equal to 0. So in our first one here, well, we would subtract 3 from both sides because these would cancel, telling me that x is equal to negative 3. And over here we would add 3 to both sides. It would tell me x is equal to positive 3. So here we cannot have x equal to plus or minus 3. We can't have either one of those. We can't have either one of those restrictions. Any questions on any of this here? Are we good with all this here? Okay. So what's in common on top and bottom? And the x plus 3. So we can cancel those out. So what's left on top? And on bottom is? And that's what's left. That's what we have after we simplified. So our answer for this is x minus 4 over x minus 3. And our restrictions are that x cannot equal plus or minus 3. Any questions on any of this here? Okay. Now, if you notice on a lot of these here, we've had plus and minus as our restrictions. It's not always going to work out that way. It just worked out that all these problems have perfect squares in the denominator, which kind of made it nicer. So if we look at this here, well, x plus 4, can we factor the numerator? Can we factor x plus 4? Well, no. One way that we know is that the degree of the numerator, the biggest exponent on top is, well, 1. They didn't write 1 in, so it's 1. So there's no way to factor it, because once the degree is equal to 1, we're done. But we can factor the denominator. But what are the factors of the denominator going to be? X plus 4 and x minus 4. There's x squared minus 16 again. That's a difference of perfect squares. Now at this point here, we can find the restrictions. So we can use the denominator here to find the restrictions. X plus 4 is equal to 0, and x minus 4 is equal to 0. Set both of those equal to 0. And solve. Well, for x plus 4, to get x by itself, we would subtract 4 from both sides, because 4 minus 4 will give us 0. So we'd have x is equal to negative 4 would be one of our restrictions. And the other one, we're not going to subtract 4. We're going to add 4 to both sides, because negative 4 plus 4 will cancel. And we'll get x is equal to 4. So our values of x that it cannot equal are 4 and negative 4. We could say plus or minus 4. That'll be the same thing. It cannot be 4 or negative 4. We cannot have either one of these restrictions. We cannot have, not restrictions, we cannot have either one of these values of x. Because if x is one of these two values, it's going to cause the denominator to be 0. We cannot have that. Okay. So let's simplify this here. So what's in common on top and bottom? And x plus 4. And we simplify that out. Well, all we have left on bottom is x minus 4. And what's left on top? Because anytime anything simplifies out completely, we're left with 1. There's no way that we can simplify stuff on top and bottom and ever get to 0. Because anything divided by itself is 1. Anything divided by itself simplifies to 1. We just don't normally write it in. And we'll have to write it in anytime everything cancels out or simplifies out completely. Any questions on any of this here? Any questions on any of this here so far? All right, let's look at one more of these before we move on to something else. We have this here. X squared minus 2x minus 3 on top, and x squared minus x minus 6 on bottom. So we're going to factor the numerator and factor the denominator. Which one do we want to factor first? Because we're going to have to factor both of them. Numerator, x squared minus 2x minus 3. Since the 3 is negative, our signs are opposite. The factors of x squared are x and x. And the factors of 3 are going to be what? 1 and 3. Now we can check this here to make sure we got the correct numbers. X times negative 3 would be negative 3x. 1 times x is going to be plus x. And negative 3x plus x is going to be negative 2x. Well, that's what we wanted. So we have the correct factors here. Okay? Well, the factors of the denominator. Well, the 6 is negative, so we're going to have a plus and a minus. The factors of x squared are x and x. If we look at the factors of 6, well, we have 1 and 6 and 2 and 3. Well, which factors would we use? 2 and 3, yes? Because we have a 3 on top. Would the 3 be positive or negative? Negative. Why negative? Right, we want the x minus 3 and x minus 3 to match up. Because if these are going to simplify, we need something to match up on top and bottom. And again, yes, like you were saying, we can check it. X times negative 3 would be negative 3x. 2 times x would be plus 2x, which would give us a negative x like we wanted. So these here are the factors. But we still need to find the restrictions. So I'm going to set x plus 2 equal to 0 and x minus 3 equal to 0. We're going to set those equal to 0. Now, some of y'all may be able to just look at these and see x plus 2 equals 0, x minus 3 equals 0, and see what the restrictions are, and that's fine. If you don't have to write it out, that's fine. You don't have to. You can just list what they are. But if it's easier to find them by actually working them out, work them out. So x plus 2 equals 0, well, to get this, we're going to have to subtract 2 from both sides. These will cancel, telling us that x is equal to negative 2, or well, really, x cannot be negative 2. And with the other one, we would add 3, because negative 3 plus 3 will be 0. Those will cancel out. And it tells us that x cannot be 3. Our restrictions for this here is x cannot equal negative 2 or 3. X cannot be either one of these values, because if x is one of these values, it'll make the denominator equal to 0. And now all we have left is to simplify. So as we already said, the x minus 3 is in common on top and bottom, so it will cancel out. And what it'll leave us with is x plus 1 over x plus 2. And that's what we'll have left over. Any questions on any of this here? Any questions on anything we've done so far? We good with this here? Yes? Okay. So we're going to start on this here, multiplying rational expressions. We won't finish this today. We'll finish this tomorrow. And really all this is saying is when we multiply rational expressions, we multiply the numerators with each other, the denominators with each other, the tops of the fractions together, the bottoms of the fractions together, and then simplify what's in common. We simplify out what's on top and bottom. And the same thing works with variables. If a variable is on top and bottom, they will simplify out. Well, the first thing we're going to look at is this here. We're going to find the product of these two here. Product of these two rational expressions. And when we do this here, we're multiplying like terms. So if we look at the numerators, 8x cubed times y, and 7x to the fourth, y to the third. Well, 8 and 7 are like terms, so we would multiply those two together. well, x to the third and x to the fourth are like terms, so those would be multiplied together. And then we have y times y to the third. Those would be multiplied together. And I'm writing this out all the way out because some of y'all are able to see what these actually multiply together to be. I'm going to go on and write it out. Now the denominators will be multiplied together. So our 2xy squared is going to be multiplied by our 4y. Those two will be multiplied together. And if we multiply our like terms, well, 2 times 4 are our 2 and 4 are like terms, so they would be multiplied together. Well, there's only x, so there's no other like terms with x, so it's just by itself. And then we'll have y squared times y. Those would be like terms. Any questions on this so far? Yes?
Why is there not little multiplication dots like in between the 7 and the x? Is it supposed to be going?
Yeah, we can have it there. I just don't write it there. I just didn't. Yeah, there's nothing wrong with having that there. Those would be multiplied also. Well, one nice thing that we do have is calculators. Because if I want to, I can type in the graphing calculator or the yellow calculator, we can put in the fraction 8 times 7 over 2 times 4 and hit enter, and it'll simplify it, yes? Calculators will simplify the numbers just fine. Don't put the variables in. Because again, if we put the variables in, the calculators have to have a value for them. They have to have value for x and value for y. So it won't give you the correct answer. It'll just give you a number. Now, when we look at this here, well, there's many different ways we can go from this here. Because we can multiply these together, yes? Or we can simplify from here if we wanted to. Now, if I multiply these together, 8 times 7 is 56. X to the third times x to the fourth would be x to the 7. When the bases are the same, we add the exponents. When the bases are the same, we add the exponents together. So y times y to the third would give me y to the, it's not written, but it's really y to the first. Because y to the third tells me I have y multiplied by itself 3 times. And if I multiply by one more y, I have how many? 4. And that's everything on top. On bottom, 2 times 4 is 8. X, because x is by itself, not being multiplied by anything else. And then we have y squared times y. Well, y squared times y is y to the third. Any questions on any of this here? Now, there are like terms on top and bottom. Because we can do 56 over 8, which will tell me that it is what? 7. As we saw here, 2 times 4 is 8. 8 over 8 is 1, so we're just left with 7 on top. Now, when we have like bases being divided, what do you think we're going to do with the exponents? Subtract them, because when we multiply like bases, we add. When we divide like bases, we subtract. Now, the way that we would write this in mathematically is we're going to say x to the 7 minus 1. The exponent on top minus the exponent on bottom. The exponent on top minus the exponent on bottom. Now, y is going to be the same thing. We have y to the fourth and y to the third. So this here would be 4 minus 3. Well, there's nothing left on bottom, is there? So I don't really need that fraction bar anymore because the denominator is, well, 1. So 7x. 7 minus 1 is what? 4 minus 3 is 1. So we get this here. Questions on this here? Are we good with this here? Now, this is again, this what I'm going to say next is what I personally do, how I look at this. I don't rewrite 7x to the 7 minus 1 and y to the 4 minus 3. I don't write that. How many of y'all can do 7 minus 1 in your head? Yeah, most of y'all can do that. You can do 4 minus 3 in your head. You can do most of these addition, subtraction in your head, yes? So when I look at this here, this is what I kind of see. Okay, we figured out 56 over 8 is going to be 7. So we have x to the 7 and x on bottom, yes? So we would subtract it and do 7 minus 1, which gave us what? 6, yes? Is it bigger on top or bigger on bottom? Which one has the bigger power? On top, yes? So the variable goes on top of the fraction bar. And that's it. I look at y to the 4th and y to the 3rd. Which one's bigger? It's bigger on top. 4 minus 3 is 1, so it goes on top. Now the difference is let's just say x to the 6th and x to the 9th. So again, we're dividing, so we would subtract, yes? Now mathematically, the way they would say it is we would do x to the 6 minus 9. Well, 6 minus 9 is what? 3, and it would be negative. Now we can't have a negative exponent, we can't leave it as negative. So to make an exponent positive, we move it from the numerator to the denominator. Well, okay, let's do it the other way that I was kind of talking about. So we're subtracting, yes? 9 minus 6 is what? 3, yes? Is it bigger on top or bigger on bottom? Bottom, yes? So it's going to stay on bottom.
So, what if you go back to the other problem?
Mm-hmm.
Say everything was exactly the same, except it was y to the 4th was on bottom and y to the 3rd was on top.
Like this?
Uh-huh.
Yeah.
Would you still have 7x to the 6th on top? Like everything else still on top, and just move the one y down?
So if we have this as 4, because 4, 5, 6.
I see what he's saying. He's saying like after everything.
Mm-hmm. Yeah, if this was switched, because let's see here. Let's say 1, 2, 3. We'll make this a 2. Because if it works out that, because this here would be y to the 4th and y to the 3rd, 4 minus 3 would give us 1, but it'd be on bottom. Mm-hmm. Yeah, we would end up putting the variables, if they're bigger on bottom, we'll put them on bottom. If they're bigger on top, we'll put them on top. It's not always going to work out that we just have one on bottom. This one just did. Okay, so sometimes it'll be that there's only one on top and everything else is on bottom. But we'll finish this up tomorrow.